Hi guys, welcome to my YouTube channel, and this video is for people who want to quickly go over the slices. This slide representation is from the discussion section I made last week with some of my friends who are also in deep learning beginners, most of them. Yeah. If you are okay with my English, my poor English, you can go to my channel and find the longer one, the longer discussion one. So let's begin. The area means this black box area is a general area that is related to the input pixel. This is the area, the upper area that is related to this input 822. And this is the output for this term because we multiplied k minus 1 times 822. I think I've read my slides very in details, so I don't have to talk too much because my English is supposed to say a lot of mathematical notations. By the way, this k is rotated. K minus 1 minus m is a rotated version of k and m, and so k minus 0 1 comes down here because it's the only element multiplied by 822. When you do the derivation with 822, that is the factor comes down here. Easy. And the last term. And this is the gas from the this is the general expression. Next, we're going to derive from math and see if these two results agree with each other. And this is all output area, partial derivative with respect to intermediate output. This is the O area index from O area, and this is narrowed down to the general version, to the bounding box, small bounding box around this input pixel position. And here under these two matches, this k comes down. The condition of the match is this one: I prime equals to I plus n. So after sign transformation, you will reach this formula at the end. So the two methods actually matches, except that this is one channel, one input channel, one output channel, and this is a k output channel, right? For this specific input channel, C in. Just pad 0 to sensitive map. This is the output upper bounding box, upper region, and you pad 1 0 to match to be at the sense as the same size as input, and then you pad another 0 here to the input area, and then you do this sliding operation, sliding and element wise multiply. So let's look at the very boundary condition. This one, partial derivative with respect to a00 here, and then is because all the elements is 0 padded with 0. This one delta 11 times k11. This is the only factor, and this time this h is not, the kernel is not rotated, indexing from k minus 1 to k11. So the derivative with respect to weights, pretty much the same method. Only at this condition, is a vector comes down here. It looks like the convolution, but actually it's not, because the index is not, it's different from this. This is the convolution formula, but the index is not the same. So here I consider the specific case where m equals to -1, m equals to -1, c is just one channel. So this is the output. The output is actually this green area element wise multiplied by this delta sensitive map. So we can conclude that we slide this sensitive map along this direction from bottom right to the top left, sliding this way, and 1 pixel up to the left, another pixel up to the left. Then you get all this derivative with respect to the weights. The batch normalization. I mean, this is the take layer 1 as this system. Each system has a requirement for their input data distribution to maximize the output performance. So this is the output data distribution given by layer L-1. So this is the mismatch between the given and required. So we add a distribution transformation between these two layers to transform this distribution to match this requirement by training. I mean, by training they were trained a good distribution transformations parameter to transform this output this data distribution from layer 1 to match the input required by layer L. And this is our given. Our given is um, the derivative with respect to the output, which is the input to the backpropagation at this level. These two are just too easy, just this one and one. So we do this part. So again, we use chain rule to expand this portion. This portion contains three intermediate elements, intermediate variables, uk and delta square and itself. So it becomes three parts, three components. Let's calculate component by component. First, this one, its derivative with itself. So it becomes this part, and this part, because the mu is become is this. So we substitute, we get this, and this become this, and we substitute into it, and we get this formula. And L and O, we get this long formula for scaling. Okay, the end. Thank you.